Hello, everyone. Thanks for joining. We'll give it a few minutes for people to trickle in. Awesome. We've got about 30 people here so far. I think we're waiting for a few more. So hang tight. You're in the right place if you're here for the Climate Forward Ambassadors webinar. Hi, Ramon. All right, I think we're gonna have people continue to trickle in, but I do wanna get started because we have a really packed agenda to try to fit into 1 hour. So thank you so much for joining this evening. Welcome to all. This is the Climate Forward Ambassadors webinar about global climate change and local impacts. My name is Hannah Payne. I am the Climate Change Program Manager with the City of Somerville. I'm joined this evening by Oliver Sellers Garcia, who is the Director of the Office of Sustainability and Environment. And hold on, let me see if I can move the slides. Okay, so many of you on the call are participants in the Climate Forward Ambassador Program, but some of you might be new to this or unfamiliar with this program. This is a program our office started in 2019, designed to help empower Somerville residents to act on climate change. So residents come together and learn about global climate change and action at the local scale, engage with neighbors from across Somerville, and complete climate-related projects. So if you, if this is the first time you're hearing about this program, I encourage you to find out more at somervillema.gov/CFA. And our cohort is full for this year, but we plan on offering it annually. So take a look at that for more. Okay, as I mentioned, we have a lot to fit into 1 hour tonight. So bear with us as we'll talk a lot at you, but we do have time at the end for Q&A. We're going to start by going over some climate change basics, talking and then go into where we're headed globally with emissions and where we really need to be headed. Then we'll drill down from the global to the local scale and talk about Somerville's climate goals, our greenhouse gas inventories in Somerville, and then also how Somerville is going to be impacted by climate change and what are our biggest vulnerabilities. We're planning to leave about 20 minutes at the end for Q&A, and there should be a Q&A section in the Zoom screen. So please type in your questions as we go. We'll try to get to as many as possible at the end. And if there's a clarifying question along the way, we'll try to pull those out and ask them as we go. So with that, let's dive right in. So starting out with some basics of climate change, and this is probably going to be a review for many of you, but I'm hoping we can make sure we're all on the same page here. So climate change at its most basic level is global temperature increases. We can look and see, based on the data, that temperatures have been increasing significantly since the industrial era. So this graph is showing the departure of global temperature from the average in 1881 to 1910. So as you can see that from that industrial era, we've seen almost a degree of warming since that time already. What is causing this global temperature rise? This is caused by the greenhouse effect. So as sunlight and energy passes through the atmosphere, it warms up the Earth's surface. And then it's radiated back into space. But with greenhouse gases in the atmosphere, those gases absorb that heat and trap it, so acting like a blanket around the Earth. So as we have increasing greenhouse gases in our atmosphere, more heat is trapped and the temperatures warm. We can look at carbon dioxide and look at the historic records and see that carbon dioxide has fluctuated throughout the Earth's history, but it has never been at the level it is today. So we know with certainty that the amount of carbon dioxide we're seeing in the atmosphere is not caused by any natural causes. It can really only be explained by human action. So you can see the really quick, rapid rise of carbon dioxide in the atmosphere from 1910 to what it is today. And then if we look at this data all together, looking at temperature and carbon dioxide mapped together, carbon dioxide being the blue or turquoise line, we see that these are really highly correlated with one another. Okay, so we know temperatures are rising. We know that it's caused by greenhouse gases in the atmosphere. Where are these greenhouse gases coming from? So the main sources of this, so carbon, CO2, being the most prevalent greenhouse gas, we can look at where this is coming from, and we see that these emissions are the result of burning coal, oil, and gas, so burning fossil fuels. And then another piece of this is from land use changes, so deforestation, agriculture, things like that. And then a smaller portion is from cement production and gas flaring. So we know temperatures are rising. We know it's because of increasing greenhouse gases in the atmosphere, which are created from the burning of fossil fuels. Okay, so that's the very simple climate change 101. So where are our emissions going and where do we need them to go? Many of you are probably familiar with the Paris Agreement, or have at least heard about it. This is the international agreement that was adopted at COP21 in 2015. And this sets a target to limit warming to below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit warming to 1.5 degrees C above pre-industrial levels. So one thing I want to point out with this is there are these different levels of that we're setting as targets for limiting climate change. But these aren't like on-off switches or specific thresholds of it's safe and then it's dangerous. We're already experiencing climate change and will continue to experience the impacts of climate change along this spectrum as we reach these thresholds. However, the global consensus has really settled on these targets. And this graphic shows some of the differences of how will globally be impacted by climate change at different levels of warming. So you can see that at 2 degrees C, we're living in a much more dangerous world than we are at 1.5 degrees C. So the goal is really trying to limit warming as much as possible. Okay, let's see if this works. Okay, great. So this graph is showing the carbon budget for 1.5 degrees C. So if our goal is to keep global warming within that limit, we have a limited amount of carbon that we can emit into the atmosphere. Carbon emissions are cumulative. So it's helpful to think, I really like this visualization because you can think of the bucket as the atmosphere. And the world is pouring in greenhouse gas emissions and carbon emissions. And you can see that we're filling the bucket quickly, right? And there's only a limited amount left for us to continue to pour in more greenhouse gas emissions. So what is the solution, right? If you were going to try to not overtop this bucket, we could poke a hole in the side, but we only have a little bit amount of that we can siphon out through of emissions that we can siphon out through sequestration. So planting trees, for example, or carbon capture and sequestration. If I were, to try to not overtop this bucket, I would want to turn off the faucet, right? So turn off the faucet of greenhouse gas emissions in order to not overtop it. So this is, I think, a really useful mental image for thinking about carbon emissions. This graph presents very similar idea in a different way. So to reach, so again, to keep warming within 1.5 degrees C, the longer we wait to peak our global emissions, the more steep that path will need to be in order to keep our emissions, warming to 1.5 degrees C. And the harder it is to do without having any major large-scale negative emissions, which is very, very challenging. So, if you look at the lightest yellow pathway here, that would be, if we peaked emissions in the early 2000s, we could follow a much more gradual pathway to stay within that target. And, if we wait until 2030 to peak our emissions, we're going to have to follow a much steeper trajectory. So I just want to pause for a second because this is a lot of information. Take a breath. This can be overwhelming and scary to think about global climate change and the impacts of it, and really how quickly we need to transform so much of our world. But I want to remind you all that while it is scary, it's daunting. We know what the problem is. We know it's from burning fossil fuels, and we have the tools to fix it. And so I think I just want you all to take that away, and we'll focus on that a lot more going forward. So with that very fast introduction, I'm going to pass it over to Oliver Sellers-Garcia, who's going to talk about Somerville's goals.
Great. Thank you, Hannah. I really like that bucket graphic as well. So I'm gonna define carbon neutrality, which you've heard us talking about a lot over the years, walk through our greenhouse gas emissions baseline for Somerville, and then give you some highlights on some modeling that we've done to see what it would be like to get to carbon neutrality. So next slide, please. So we use the term carbon neutrality and net zero carbon emissions interchangeably. And what we mean by that is that it is that on an annual basis, we reduce emissions to zero or as close to zero as we can. And if we haven't been able to, we have to find some way to offset it so that it nets out to zero. And as Hannah explained, at a global level, that is the target that is needed to keep global temperatures below a catastrophic level for human activity. This is the science-based goal that has been adopted by pretty much every international science-based organization that is seeking to have uniformity on climate goals for cities and subnational governments. We're a member of some of these on the slide. Next slide, please. So now we're going to talk about our emissions in Somerville. And just to frame it a little bit, The adage or cliche is you can't manage what you can't measure. So that is one of the principal reasons for why cities like Somerville do greenhouse gas accounting. And I'll give you a few other goals for doing this to keep in mind. So it really helps communities put things into perspective. We know that in the United States, around 10% of emissions come from agriculture. There's not a lot of agriculture in Somerville, so we need something that's more tied to our particular community. It helps us measure things over time. So we do our greenhouse gas inventories every 2 years. And so we're able to see how things change. And it also gives us a starting point for policy decisions and advocacy positions that we need to take so that we are really informed by data about what the particular issues are that we have some control over or need for here in Somerville. So now I'm going to share with you our greenhouse gas profile. So what is in an inventory? I'm going to direct you to the right part of the slide. So there's a lot of jargon in this. It's a very technical methodology, and I'm going to try to really simplify it. Inventories are broken down into scopes, and that's basically just sort of like components. Scope 1 is fossil fuels that are combusted in the community. So think heating oil or gasoline. Scope 2 are greenhouse gas emissions that come from the energy we consume and purchase. So that is a recognition that most of the electricity, for example, that we consume in Somerville is not generated in Somerville, but it is brought here and it is integral to the fossil fuels that we're consuming. And scope 3 are other emissions. And this is where you start to see a lot of variety between municipalities or other jurisdictions, because it really depends on what's in your community and what you have data for. So for example, we include transportation and waste. But then on the other hand, we don't have an airport, so we're not going to try to include that, but you would see that in another community. So roughly speaking, that is like the universe of data that we look at in a greenhouse gas inventory. We follow the Global Protocol for Community Scale Greenhouse Gas Inventories, also called GPC, which is the standard. And our inventory about city operations, which I'll touch on at the end, also follows global reporting protocols. So, generally we're doing what is the leading scientific practice. So I'm going to explain this all to you, and I'm sure many, if not all of you, will think, well, what about this? What about that? I could think of a better way to do it. You probably can, and it's definitely worth talking about. This is not perfect, but it's the way that it's typically done, and it is a fairly accurate characterization. Next slide. So I'm going to focus on 2016, which is not the first year that we did this, but it's a fairly recent year that has complete information. So in Somerville, 2/3 of our emissions come from buildings. That's called stationary energy. 1/3 of it from transportation, roughly, and then a tiny portion, around 3%, from waste. That's the headline. So I'm just pausing for a second to let that sink in. So 2/3 from buildings, 1/3 from transportation, and just a tiny bit from waste. Okay, going on to the next slide. So there's another way to look at it, which is, what are the fuels behind this? So this is a breakdown of the building sector, and you can see that between buildings that are residential buildings and commercial buildings, there's actually, some differences in terms of where the emissions come from. So in residential buildings, it's far and away from natural gas. And then in commercial buildings, it is electricity composes the largest fuel source of our emissions. So moving on to the next slide. Now we're going to take a closer look at waste. This is something that is really interesting for folks, and I'd say is probably the single biggest surprise when we talk about our carbon footprint. So let me tell you a little bit about this. Waste is just overall a smaller portion of emissions of most municipal inventories in this country compared to transportation and buildings and energy. So currently our waste in Somerville goes to a waste to energy incinerator and not a landfill. So methane is a smaller part of our carbon footprint than you would hear from in many other parts of the country. Another thing to keep in mind is that because our waste is sent to an incinerator that creates energy, we're also, we're factoring the net impact of that, but we're also looking at the greenhouse gas emissions from the particular materials that constitute our waste. And volume and weight does not mean that it is proportional to the greenhouse gas impact that it has. So I'll draw your attention to the pie chart on the right, where almost 90% of our emissions come from plastics, which are made from fossil fuels, but they really only constitute 16% on average of our waste stream. Organic waste, on the other hand, so that's food or yard waste, things like that, it makes up almost 40% by weight of our trash. But think about it, there's lots of water in there. It's organic material. It has a very different emissions profile, and it ends up constituting only 1% of waste emissions. So that's a tiny fraction of 1% of our overall carbon footprint. So next slide, please. We also do an inventory every 2 years of our emissions as a city government, like any large company or corporation. This is also something that people do to hold themselves accountable. Our emissions only constitute less than 2% of all of the community, but we also have a pretty different profile, as would make sense. So buildings are a much bigger part of our emissions, and it's not on this graph here, but electricity is by far our biggest source within the building sector of our municipal emissions. So that is where I'm going to end the summary and talk a little bit about what do we do with that information? Well, all sorts of different things, but the main reason we're doing it is to fix problems and make some plans. And then the next step is really to understand what could we do to really make a difference. So you look at that pie chart and say, okay, 2/3 of emissions come from buildings. I get the sense that we should do something with residential buildings. What should we do there? Okay, so we did a study a couple years ago where we, moving on to the next slide, where we said, okay, so emissions are gonna keep growing if we don't do anything. And we know we need to get them to zero. So let's see how we can basically get there, fill in this big sort of yawning gap between doing nothing and getting to zero with some realistic, achievable methods that we know from like a technology standpoint can zero out emissions. Can we get to zero? How close to net zero can we get? And we did this based off of our 2014 inventory, and we used a tool that was being piloted at the time. We were lucky to get it early and is now used by the C40 cities, which is a leading group of large cities working on climate change. So next slide. So this is a table that I don't want you to get too drawn into, but it basically shows our growth assumptions. And what I'll say is that looking at these assumptions and understanding how much emissions per capita we have now and need to get down to, we wanted to answer some questions with our modeling. So just by the numbers, what policies and technologies are going to have the biggest impact? And will there be any emissions left over? And as I mentioned, how far will they get us? So before I show you these results, I want to preface it by saying that this is not a plan for how to get there. It's really just a test to see what could potentially work. And then we figure out how to plan for it. So next slide. So what you'll see here is a summary of where this would all go if we use some different technologies and policies. And I'm going to highlight some of the most impactful ones. The yellow portion is if we have carbon-free electricity that phases in pretty rapidly. That could get us basically 30% of the way toward carbon neutrality. But just sort of look at the beginning and end of this time scale, and you'll see that if that's all we did, we'd basically be still like a little bit higher than where we started. So we need to build off of that. We need to add other things. And so the orange section is switching building energy totally to that carbon-free electricity. And that would take us an additional 25% of the way there. Then there's the purple section, which is switching vehicles from gasoline to electricity. So now we're getting really close to net zero. So there's some other things I want to point out. Then there's the strategy that you might see here called transit-oriented and mixed-use development. That doesn't really do very much. And that is because, guess what? We already did that. We've been a dense transit-oriented community since the 19th century. And so this strategy would be really effective in Southern California, for example, but it wouldn't be here. So what this modeling study showed us is that we have known, understood policies and technologies that can get us very close to net zero if we apply them all the way. And it kind of sets the starting point for figuring out how to bring them to Somerville, Massachusetts, United States. You'll also notice that there's a little sliver that we didn't get to, and that's on the next slide. So of course, in theory, we could probably, I mean, this is a model, we could work it so that it gets to zero and pat ourselves on the back, but we would try to be realistic and say, there are some things that, there aren't easy answers to. And those are primarily leaks in the natural gas distribution system. And then there's also some, realities of solid waste and wastewater and big construction vehicles that there aren't feasibly going to be able to be transitioned to electricity that are still around. And so, there's a few ways to look at this finding. One is, all right, we really need to get serious about not just switching away from natural gas, but, decommissioning the system. No one uses it, so there isn't pressurized gas under the streets of Somerville, even if we're not using it. Another way to look at it is, all right, let's start preparing for potentially some offsets. And that doesn't necessarily mean buying something in the market. It means maybe some more regional solutions or producing more energy in Somerville. There's other ways to get that net zero effect at the end of the year. So one of the takeaways that I want to leave you with is that we can get really close to net zero in Somerville, but we aren't going to be able to do it most likely totally by ourselves. And so we need to obviously engage with the world around us to offset that. And so in closing, before I turn it back to Hannah, I'm going to boil everything I said down to something even simpler. So forgive me if you have more complex questions, but all of this work basically takes us to a really logical set of conclusions, which are, we have to do three things kind of in tandem and working off of each other. We need, because in Somerville, our emissions come almost entirely from our use of energy, we just need to use less energy. We need more energy efficiency. Whatever energy we continue to use really needs to be carbon-free electricity, right? We have the ability to generate electricity. Let's just make sure it's carbon-free. And then, or at the same time, we just need to switch off fossil fuels, and our driving and our heating and cooking needs to be electric so that we're using that carbon-free electricity. Those are the three cornerstones to greenhouse gas reductions. Hannah, back to you.
Okay, thank you. So before we switch gears from talking about greenhouse gas emissions in Somerville to how Somerville will be impacted by climate change, I just want to put a plug in again that you can be entering questions into the Q&A section. If you do that, others can see it. If you put it in the chat, only Oliver and I can see it. So put them in the Q&A section and we will get to them at the end. Because I'm sure you're having lots of thoughts as we're talking. Okay, so we're going to switch gears and now talk about what does climate change look like in Somerville. So let me see if I can get the slide to change. Here we go. Okay, so like we did a greenhouse gas inventory to understand what our baseline greenhouse gas emissions are, we also did a climate change vulnerability assessment to understand how will Somerville be impacted by climate change. And we completed the study in 2017 and looked at 3 major climate exposures in Somerville at 2030 and 2070. And so the 3 climate exposures we looked at were heat. So temperatures, as I talked about before, are rising globally. This means in Somerville, our winters are getting warmer and our summers are getting hotter. We looked at precipitation, and we looked at coastal flooding. And so I'm going to go through each of those in a little bit more detail of what that looks like in Somerville. Okay, so starting with heat. Extreme heat is really a public health issue. Hot temperatures and heat waves are actually the weather event in cities that cause the most deaths. So we know that heat is a real problem and not one that we're really used to dealing with, especially, this week with a big snowstorm. Being New Englanders, we're like, oh, warm weather, this is great. But as we experience climate change, our summers are going to get hotter and our climate is really going to be quite different than what it has been in the past. So if you look at the graph, this shows that in the past, if we look historically, on average, we would experience about 11 days over 90 degrees in the summer. By 2030, this is likely to be between 20 to 40 days over 90 degrees. And by 2070, this could be up to 90 days over 90 degrees. So just think about that for a moment. That would be about 3 months of temperatures over 90 degrees. That's a really different summer than we are used to experiencing. And you're probably noticing some of this already. We have had, the summer of 2018 had 20 days over 90 degrees. So the second point I wanted to make is about how we experience heat. So it's one thing to say temperatures are going up, but when it's hot out, not all, we don't experience heat in all the same way. So if you look at this map of the region, this shows average daytime land surface temperature. And the blue areas are the coolest areas. So those are bodies of water. And the red areas are the relatively hotter areas. And you can see that what areas are orange or red. They're the dense urban built up areas. And this is because buildings and pavement absorb and retain heat more than trees and open space do. And so naturally you see that urban areas are hotter. So when it's 90 degrees for several days, it will feel hotter in Somerville than it will in Newton. And you've probably experienced this of, wanting to get out of the city. Maybe you go to a walk in the fells when it's really hot out, or you want to go to the beach to kind of get out of that feeling. So this is all to say that the strategies that we implement to prepare our community for heat look different than they might in a more suburban or rural community because we're working with this, because we experience the urban heat island effect. Okay, the next exposure that we looked at is precipitation. So in New England and in Somerville, with climate change, we're going to experience larger storm events. So by 2070, we can expect to have 30% more precipitation in major storms. So more water falling. And this map here shows a modeled storm in 2070 that is a 100-year storm. So that's a common way that storms are described, but really what that means is it has a 1% chance of happening in 2070. So that's 100 years. So 100-year storm. This map is also taking into account what sea level rise will look like in 2070, because one of the big things with precipitation, it falls, it lands, and the water has to go somewhere. And so if we have if the river is higher and the outfalls can't convey that water out of the city as quickly, that leads to more flooding in the city. So this map is showing a modeled storm of that 1% annual chance of a storm in 2070 with 2070 sea level rise. And the other thing that's interesting about this map is that it shows it's modeled with Somerville's drainage system. So we worked with the engineering department on this. And so it takes into account how the water would be conveyed out of the city and what parts of our system would back up and lead to flooding. And so this is kind of showing the worst case, like a really intense storm, a really big storm in kind of a worst case scenario in 2070. But for anyone who's lived in Somerville for any period of time, who's lived here long enough to have a large rain event, thunderstorm, you've probably seen a scene like this, right? Where rain falls quickly, it can't be conveyed out of the system fast enough, and it pools on the street, causing street flooding. So precipitation, as we have those more intense rainstorms, is already causing these, this nuisance flooding on our streets, and is something that we're working on improving the system so that we can convey more water out of the city, knowing that we're going to be having more events like this in the future. Okay, and the third exposure we looked at was sea level rise and storm surge. So these maps, it might be a little bit hard to read all the text on here, but the map on the left is 2030 coastal flood probability, and the one on the right is 2070 coastal flood probability. And this is taking into account about 3.4 feet of sea level rise by 2070. One thing to note about Somerville's coastal flood exposure is that, unlike Boston and many of our neighboring communities, we don't have too much of a exposed coastline. So we really will experience coastal flooding during large coastal storm events, so a nor'easter or a hurricane. And there's really two ways that the water will come into Somerville. The first is the Schrafft Center pathway through Charlestown, and the second is around the Amelia Earhart Dam. And what's interesting about this is that neither of those pathways are under the city of Somerville's jurisdiction. So the Schrafft Center pathway, that water comes in through Boston, and the Amelia Earhart Dam is an asset that's owned and operated by the state's Department of Conservation and Recreation. So this first pathway is through the Schrafft Center, as I mentioned, or not through the Schrafft Center, but right by it in Charlestown. And the water would come in through this low-lying area near Sullivan Station and flood areas of the Inner Belt. This image is from Climate Ready Boston. So one of the great things about being where we are is that our neighboring communities are really taking climate change seriously and are also developing their own plans for climate resilience. So this is from Boston's climate resilience plans, and they have strategies to elevate and protect the coastline around Ryan Playground and the Schrafft Center, as well as have some interventions that are within the road to elevate that so that the flooding would be stopped in Boston and wouldn't come to Somerville. But this is the first pathway, and it's a nearer term risk because this is such a low-lying area and it's not protected by the dam. The second pathway is through the failure of the Amelia Earhart Dam. And this dam, for those of you who haven't visited it, I would recommend it to go take a look at it. It's pretty cool to look at. So this aerial photo shows the Assembly Square T station right in the bottom left-hand corner and Draw 7 Park. And that's where the dam is. And this dam was built to prevent flooding in Malden and Medford, and now separates the tidal portions of the Mystic River, so that connect to Boston Harbor, and the non-tidal part that goes all the way up to Mystic Lakes. And with sea level rise and storm surge, this dam was not built with sea level rise and climate change in mind. So with those that new scenario that we're facing, the dam could be flanked during that 1% annual storm or a 100-year storm as early as 2035, and could be overtopped during that 100-year storm as early as 2055. And so that's why you see that change in the two maps that I showed of 2030 versus 2070 and the impact of flooding. And the Amelia Earhart Dam is an important asset, not just for Somerville, but if we look upstream, the Mystic River, so you can see large parts of Medford would flood if that dam is overtopped, as well as all the way down Alewife Brook into Fresh Pond and parts of Cambridge. And it's really important when we're looking at coastal flooding, we can think about how do we protect Somerville, the properties in Assembly Row, really focus on our own borders. But once you zoom out, you realize in a large coastal storm event, so much of our region would be impacted. And, it's maybe different during COVID, but during, pre-COVID, very few of us would spend all of our time and days in Somerville, right? So what happens in Cambridge affects Somerville. What happens in Boston and Medford and Arlington and Chelsea have an impact on Somerville. And so if we're really going to be resilient to sea level rise and coastal storms, we need to have a regional strategy to protect from these scenarios. Okay, and then the last dimension of climate vulnerability that I want to introduce is, it's not just about exposure to climate impacts. We also have to think about who is most vulnerable. So we can think about this in terms of sensitivity to those climate exposures. So, these are things like age and health might make you, so if you have asthma, you might be more sensitive to high heat days because it's harder to breathe, or you might have health problems because of that. The second dimension is adaptive capacity. So these are things that make it easier or harder for some people to respond to an impact and get out of harm's way. So things including wealth or financial assets, so or mobility. If you own a car, you could get out of town before a flooding event. Or if you have limited mobility, it might be harder to get out of your apartment if the power goes out during a flood or a heat wave, if you rely on an elevator. So those are some of the things that affect vulnerability beyond just who's exposed, because while we will all be affected by climate change in some way, we won't all be affected equally. And so we really need to think about who is going to be most impacted and who is most vulnerable, and how do we build solutions to make sure that certain people and certain communities aren't disproportionately harmed by climate change. Okay, So that was, again, a very quick overview of what climate change will look like in Somerville. And we gave you a lot of information about our baseline and kind of what we know. All of this fed into creating a climate change plan that's all about action and solutions. Unfortunately, that's not what we're talking about tonight, but we have plenty of time to talk about that. And that's what the future webinars in this series are dedicated to. So in March, we'll be talking about building and energy solutions. In April, we'll talk about transportation solutions. And then later in April, we'll talk about climate resilience and public health. So I know that, it's really, that's where your mind wants to go is, okay, what do we do about it? And I just want to say we'll have plenty of time to go there. And apologies for not being able to get there tonight, but I hope you join us later. So with that, I want to, we're going to end the formal part of the presentation and have time for questions. And I saw a bunch rolling in, so I'm going to actually stop sharing my screen so I can better see the questions. Okay.
So I would suggest we start with a question that was actually in the chat from Jackson Clausen, which is, if the world was carbon neutral, would temperatures start going down, or would the world need to be carbon negative to reverse that damage? I can answer it. Hannah, you can answer it?
Go ahead.
All right, you can just fill in all the blanks and correct my mistakes. So this is a really good question, which is part of the reason I wanted to select it first, because it explains something that, I'm sorry, I think we all need to look at Hannah's beautiful landscape photo again to chill out a little bit. But if we went carbon neutral like today, the best estimates are that we would still continue to see an increase in the temperature and all of the consequent impacts for around 50 years. So I'm sorry, guys, if you're like my age, we're going to be living with a warming, not just warm, a warming climate, probably for the rest of our lives. And then the benefits of decreasing come after that. So that's the truth. So would the world need to be carbon negative to reverse the damage? So I guess that's also, I'd say that's maybe a little less easy to answer with modeling. I mean, I think a lot of us in more of like the policy world and the science world are really shooting for just stopping catastrophic change as opposed to reversing. But of course, anything is possible. We just have to really think about what that, sort of like the downward tail of that peak. So like going up for 50 years and then going back down, and how to, what the world looks like after that. So Hannah, I don't know if you want to add anything to what I said.
I think you've covered it. I don't have much to add. So yeah, it's hard to wrap your head around. But I think, the real priority right now is slowing down the rate of change is, I think, the only thing I would add to that.
I hear you loud and clear, Hannah, about trying to answer some of the questions about the analysis and the baselining first. So people have some really good questions that they've been putting in, but I'm going to suggest maybe prioritizing some of the ones that are more about like, so what's the situation here? And so here I see a question from Abe Gladstone. Do you have any seasonal information on carbon emissions in Somerville? What seasons appear to have the highest CO2 emission? Interesting question.
Yeah, that's a great question. I wish we had really good seasonal information. Data is definitely one of the challenges that we have with really good and accurate greenhouse gas reporting. So while we don't necessarily have like seasonal data, especially on, transportation, we don't kind of dig into that level. There are some things that we can look at based on seasons and know. So we do get information on how much natural gas we consume as a city from all of the customers from Eversource and National Grid. And that's definitely highest in the winter, right? So we're burning more natural gas in Somerville to heat our homes. And we use more electricity in the summer when we're trying to cool our homes. So that's kind of the thing I can point to the most. Oliver, I don't know if there's anything you would add to that.
Yeah, we also get data for all of the residential electricity consumption because we have a community choice aggregation program. And you wouldn't be surprised that, you know, usage goes up in the summer when people are cooling more. I do think an interesting question that you didn't ask, but that comes off of that is when we accomplish all of our goals, what are the seasonal changes and what implications does that have for you know, how we manage the generation of electricity and the distribution? And that's kind of, you know, beyond the city level, but just think about it like, you know, if we're not just using power for lights and, you know, running the dishwasher when we're at home in the evenings, but now it's going to be, you know, heating and also charging cars. It's going to change during the day. It's going to change over the seasons. So that's something interesting to look at too. We also have a question from Annegret Klaue. Forgive me if I have mispronounced your name. Do the emissions from transportation for Somerville include emissions to which the city is exposed from traffic on I-93? That's a good question, and I have an answer for that. So we followed the sort of, as I mentioned, we follow pretty typical protocols for quantifying the emissions. And part of it is basically, we try to do our piece so that all the other pieces, if done the same way, would fit together for the whole. So we don't count just everything that passes through Somerville. What we count are all trips that are vehicle trips that are within Somerville. So they start and end in Somerville, and then half of all trips that either begin or end in Somerville. So my guess would be that the vast majority of you know, traffic on 93 is not going to be counted because those trips aren't beginning or ending in Somerville. And the truth is that, you know, a regional transportation model, if it's used for regional emissions, should capture that. And you know, our emissions are basically part of the, you know, the global sum. So what, you know, the question you're asking makes us think this is maybe more on the adaptation and resilience side of it, which is to understand what are the, you know, heat, air quality, and other health impacts because of 93, and how do those interact with changes in climate, not necessarily just the greenhouse gas emissions from it.
All right, I found a question that I think would be good to answer, though okay. How much control does Somerville have over the energy mix? Are there incentives for residential energy generation? So Oliver, I don't know if you want to answer this one or I can take it.
No, that's fine. I'm trying to catch the questions and answer them, but I'm just gonna actually answer them instead of trying to log them in Zoom. So the answer is yes and no, a little and a lot. It depends on how realistic and optimistic you are. So sort of big picture, we get our power from the grid, and that is not something that we get to completely choose, right? So that's sort of like the economics and the regulation of the New England power grid. And that is influenced by legislation and all sorts of other different things. So in some ways you can say like, well, this is not totally Somerville's decision to make. However, we do have a municipal aggregation program, which many cities and towns in Massachusetts now have too. And that basically allows the city to choose the supply for its customers. And so we've done that, and we've added more renewable electricity to the grid in proportion to Somerville's consumption. So we've done that while keeping prices low. So in theory, we could say, you know, prices be damned, and we go all the way to 100% renewable electricity. We all start paying a lot. And then we do have legally that control, but it would really be detrimental to lots of folks in Somerville who are, you know, have financial concerns or, you know, who don't want to make that choice. So the strategy that we're working off of is let's do as much as we can to, you know, in an economically sensitive way, change the supply in Somerville. But then let's really work at where the difference is going to happen at a larger level that will actually, you know, affect global emissions, and that's at a minimum at the state or regional level. And so that's really pushing for and supporting legislation that changes the requirements for how much utilities have to buy from renewable energy, making renewable energy easier to, you know, come online, supporting that economy. Those are all the things that actually change the grid for everyone, including Somerville.
Okay, so I saw a couple questions asking how do we work regionally on climate change, and we'll get into this some more during other webinars, but the short answer is we work all the time regionally. So we work often with the city of Boston and Cambridge, Medford, and we're also really engaged through the regional planning agency in the area, which is called the Metropolitan Area Planning Council. And they coordinate the municipalities. I can't remember how many, 11 municipalities in the
15 now.
15. Okay, got that completely wrong. That are immediately around Boston, so in the urban area, that come together and collaborate on climate change. And all of our mayors and city managers have made commitments to be carbon neutral by 2050 and to work together on climate resilience. And so that has been a really amazing collaborative effort. In addition, there's another group that's facilitated through the Mystic River Watershed Association that looks at climate resilience and really works collaboratively on climate resilience within the Mystic River watershed. So there's a lot happening in the region. And I think that's really one of the strengths of being in our area is how much action there is on that. Okay, I'm gonna do this question because it's related to our emissions. Inventory, do we track methane emissions? Is there anything being done about natural gas leaks?
So we include methane. Well, no, methane, no, but we do have the natural gas leaks as a portion of the of our greenhouse gas inventory that we attribute to leaks in the system. And I'll say that this is a modeled number. There's really good analysis behind assuming how much is actually leaked in the system, but we don't know the exact amount. So tracking methane, I think this is a perfect example of you know, where your community is different, you would track it. So if you had agriculture, definitely you would. If you had a landfill, if your trash went to a landfill, all those sorts of things would make you want to track it. Is there anything being done about gas leaks? There's a lot, and it's too much to get into. So hold that question for the next webinar when we talk about that, because it's a kind of a chicken and egg question about how we deal with the gas leaks, or maybe decide not to and just move away from gas. Interesting questions there.
Okay, since we're nearing the end of the hour, I'm gonna do a speed run through the questions that we haven't gotten to yet and talk about when we're gonna answer them. So Ryan Kingston, I know you've been waiting patiently. How will Somerville support EV charging infrastructure, especially for renters? I love that you asked this question. We've done so much work on it, a whole report. Come to the transportation webinar. We will be spending half of the presentation just talking about EVs, what we're doing with EV charging, particularly for renters and those in multifamily households. So stay tuned for more. Is Somerville working with utilities to provide opportunities for energy efficiency to homeowners and renters in all neighborhoods, income levels? Yes, come to the webinar about building solutions. We're going to be joined by Christine Andrews from our housing division, who works very closely with the utilities on the Mass Save program on the residential side. So we'll be answering more about that, but in short, yes, the main way that energy efficiency programs are run is through our utilities and through the Mass Save program. Okay, how are we incentivizing switching to electric vehicles? Yes, you're right that a huge chunk of CO2 is from passenger vehicles in Somerville, so we need to electrify those. So come to the transportation webinar to learn about how we're both going to incentivize folks to get out of their cars and electrify. Next question, please tell us a bit more about removing gas infrastructure from Somerville. Are plans underway? I think we'll also get into this during the buildings webinar. It's a really tricky question to answer. We're definitely working towards electrifying our buildings as much as possible. And one thing I'll note that we can get into later in an ambassadors meeting as well, a little bit more, is there's the Department of Public Utilities has a case open that's really having the utilities look out the future of kind of getting off of gas and what that looks like. So hopefully there will be more to come after that gets underway a little bit more. Someone notes they barely use their heat this season. I know, winter's my favorite season. I want snow all the time. So it bums me out too, even if it's better for emissions. We talked about these regional questions. Okay, is your department teamed up with the public health department to address pollution's effects on health? Yes, we work with our Health and Human Services department, and we've been doing a lot of work specifically this year around the health impacts of heat. So not specifically indoor air quality as much as heat exposure, but we definitely do collaborate, and we'll get more into that during the webinar, the fourth webinar, which is about public health and climate resilience. Ivan asked a question about real estate development, and if stationary energy is a big contributor of greenhouse gas emissions, what is the city doing to encourage or force those investors to build better with energy efficiency materials? I'm going to say again, come to the buildings and energy webinar. We will get into this. We have a new zoning code in Somerville, which does a lot to incentivize sustainable development. So we'll get into the nuts and bolts of that during the buildings webinar. I'm happy to talk more about it as well. Sophia asked about Mass Save programs, buildings webinar also, but the question is really about power strips, turning off lights after you leave seems not to be close to the solution, that it's not enough. I think you are right, Sophia. We need to be doing much more than just turning our lights to LEDs and using a little bit less energy here and there. What you might not know is Mass Save actually has a whole suite of lots of really big incentives and programs that cover all things from weatherization and insulation, all sorts of things. So they go way beyond just those small interventions. However, they're a lot harder to access for folks who are renters. So that's definitely a real challenge that we have. Okay, and okay, I think I got through most of the questions. There's been some exchange about the community choice electricity aggregation and some options. So Dan, thanks for chiming in with an answer there as well. So I don't know if Oliver, you want to add anything to that, but I think I got through most of the questions.
You did. That was great. I sent a private message, so I think we're good there. Okay. So thank you all so much for joining.
I hope this was informative, and I look forward to seeing all of the ambassadors that are on this evening on the 18th for our next meeting. And this meeting is also recorded, and we'll be posting it online. So if you want to share it with someone later, it will be up on the city's YouTube page, so you can look for it there. So again, thanks for joining, and I hope you have a good rest of your evening.
Good night.